Okay, let's unpack this.
Mm-hmm.
If you've been following the global cybersecurity landscape,
Mm-hmm.
I mean, the last few months have felt less like a steady current and more like just a chaotic storm.
A total storm, yeah. We've seen major zero-day fixes, hospitals like AZ Monica in Belgium shutting down servers.
And those massive data breaches, Betterment, for instance, it just feels relentless.
It is. And, that high-pressure, chaotic environment is precisely why the discovery we're focused on today is so, so critical.
Right.
We are distilling findings from analysts at Checkpoint, and they found a new, highly advanced piece of malicious infrastructure. It's called VoidLink.
VoidLink.
Yeah.
And from what I'm seeing, it's a cloud predator
Yeah.
built from the ground up for Linux environments.
That's a good way to put it.
So our mission in this deep dive is to understand not just, the laundry list of its capabilities, but really fundamentally why it represents such a big leap forward.
Exactly. And the core insight for you right at the top is this. VoidLink isn't just another tool. It's a meticulously engineered, fully documented framework. It's written in modern languages. We're talking Zig, Go, and C.
So this is not a weekend project.
No, not even close. This suggests a finished product, something intended either for commercial sale, like a malware as a service, or for highly customized use by, say, a state-level actor. We were looking at enterprise-level development.
Applied to cybercrime. That completely changes the conversation, doesn't it? It implies professionalism, serious financial backing.
A long-term project, exactly. So, moving into our first section, let's define this threat by its DNA.
Okay.
At its core, VoidLink is a modular post-exploitation framework. It's designed specifically for Linux systems running in modern, large-scale cloud infrastructures. It's cloud native.
And when you mention those languages, Zig, Go, see that combination, that tells a story.
It does.
It speaks to a very high level of technical expertise, a
Mm,
real focus on performance and stealth.
it is. The analysts pointed out the immense engineering effort. The code's under active development, but the truly remarkable part is the extensive, polished documentation that comes with the framework.
Documentation.
Yes. And that documentation, in their opinion, is the strongest indicator of commercial intent. They built a product that someone else is supposed to buy, deploy, and then manage.
It's a weapons manual, a user guide for conducting the most sophisticated cloud attacks.
And we do have some initial clues about the developers. Based on interface locale settings and some specific code optimizations, the authors appear to be Chinese-speaking.
Okay.
But here's the crucial fact, the thing that really reinforces that product for sale idea.
Ritz,
As of right now, no widespread active infections have been confirmed.
We're talking about a powerful, highly polished weapon that's been built and packaged, but it might just be sitting on a digital shelf,
Waiting for a customer.
waiting for the highest bidder to pull the trigger.
That is the chilling reality. The architecture, the sheer volume of features. It all shows the authors wanted to create a, quote, sophisticated, modern, and feature-rich framework. One that minimizes the friction for the user, the attacker.
The productization of offensive capability.
That's it.
Let's dig into section 2 then, because this is where it feels like VoidLink moves beyond just being a toolkit and it becomes something more intelligent.
It has situational awareness. That intelligence is all about environment profiling. The implant's very first action, the moment it's active, is to ask, where am I, and how well defended is this place?
And it asks that question with a very modern cloud-focused lens. It specifically checks if it's running inside Docker or Kubernetes.
Right, and it queries cloud instance metadata, hunting for the big providers, AWS, GCP, Azure, Alibaba, Tencent.
And the documentation even showed plans to add more. Huawei, DigitalOcean, Vultr, it's aiming for total coverage.
And beyond just the cloud host, it goes deep. It gathers the kernel version, the hypervisor, all the running processes, the network state. It's building a complete dossier on its target.
And here's where it gets really interesting for me. The part that I think fundamentally changes the defense game is how it uses that dossier, the calculated risk score.
The risk score, yeah.
Can you walk us through that?
Think of it this way. VoidLink doesn't just look for an open window. It inventories every single security measure in place and then assigns a threat level to its own presence.
Okay.
It calculates this risk score based on scans for EDRs, endpoint detection and response tools, kernel hardening measures, and all sorts of monitoring agents.
So it's like a highly trained burglar who doesn't just check if the door's unlocked.
No.
He checks the alarm provider, The window locks, even the kind of dog in the yard before deciding whether to use a crowbar or a stethoscope.
That is a perfect analogy. And if that score is high, meaning the environment is heavily monitored, the framework adjusts, it changes its behavior.
And does that just mean slowing down?
It does, but that slowing down is strategically critical. If the risk is high, it might perform dramatically slower port scanning, spreading the activity out over hours or even days.
To avoid detection.
Right. Or, and this is key, it might increase its beaconing interval, the time between calling home to its command and control server. It could go from minutes to hours.
And that's designed to defeat security tools that are looking for a quick burst of malicious activity.
Exactly. It forces defenders to look for very subtle, slow anomalies instead of the obvious spikes.
That's a fascinating twist. We're all trained to look for speed for sudden changes. VoidLink forces us to look for sloth.
And all this intelligence is wrapped inside a custom communication layer called VoidStream.
Right. The secret channel.
It's the communication backbone, and it's built for maximum stealth and redundancy. It's a custom encrypted messaging layer designed to make all that C2 traffic look like normal, benign web or API activity.
But its real power is in the different protocols it can use, right?
That's its redundancy. It has multiple ways to call home. It can use standard HTTP, WebSocket, but also DNS tunneling.
Which is incredibly hard to spot.
And even ICMP. So if you, as a defender, block its web traffic, it just reroutes through DNS requests or even simple pings. This diversity makes it incredibly difficult to sever that connection for good.
The intelligence, the evasion. It's staggering. But now that it's profiled the system and called home, let's get into the weapons it deploys. Section 3. The modular toolkit and anti-forensics.
The strength here is its true modularity. VoidLink loads its tools as ELF object files, and it loads them directly into memory as plugins.
So they never touch the disk.
Right, and they call the framework's APIs using direct syscall system calls, which helps them evade a lot of standard application-level security hooks. The default configuration alone is massive. It comes with 35 distinct plugins.
35 tools. And what are the high-value targets these plugins are designed for?
Well, they fall into categories that just scream infrastructure compromise. You have your standard reconnaissance tools, of course, but the really valuable ones are focused on the cloud architecture. It has dedicated container enumeration and escape helpers.
So if you're in a Docker container, it has tools specifically designed to break out.
To break out and get to the host system, which is the holy grail for an attacker in a multi-tenant cloud environment.
Absolutely.
And then there's the credential harvesting suite. This is where the money is. The plugins are built to scrape everything. SSH keys, Git credentials, tokens, AXI keys, browser data.
And for anyone managing cloud infrastructure, those API keys are 1,000 times more valuable than a credit card number.
Oh, absolutely.
Well,
once they have the keys, they bypass the malware entirely. They just log in as you.
And the framework seems to dedicate just as much effort to making sure it sticks around and, maybe more importantly, covering its tracks.
The persistence is varied, dynamic, linker abuse, cron jobs, you name it. But the anti-forensics capabilities are really the mark of a commercial, high-stakes threat.
It's about protecting the asset.
And the customer. It does standard log wiping, history cleaning, but also time stomping.
Changing the file creation and modification dates to mess with any timeline analysis.
Thanks.
And, of course, it needs to stay invisible while it's active, which brings us to the rootkit capabilities.
This is maybe the most impressive technical part. The rootkit modules hide everything. Processes, files, network sockets, even the rootkit itself.
But it's not just one rootkit, is it?
No. This is where that intelligence comes back in. It adapts its technique based on the host's Linux kernel version.
So it custom builds the invisibility cloak based on the host's own security model.
Precisely. For older systems, it might use something established, like LDP or reload. But for modern systems, it can deploy sophisticated eBPF-based rootkits.
And for anyone who isn't familiar, eBPF runs programs inside the kernel itself. It's powerful, but weaponizing it
Is a game changer. An eBPF rootkit is incredibly difficult to detect because it's operating at such a deep level, and it can bypass a lot of the traditional security hooks that are looking for, say, loadable kernel modules or external processes.
That kernel-level adaptation is a huge headache for defenders. You can't just rely on one detection method across your entire fleet.
You can't. You have to account for multiple strategies being deployed at the same time.
And if, despite all of this, the implant is somehow detected, VoidLink has a final trick up its sleeve.
The get-out-of-jail-free card. Self-deletion.
Walk us through that self-destruct mechanism.
So it has these advanced anti-analysis and self-preservation systems running constantly. It's actively detecting debuggers, using runtime code encryption, and performing integrity checks on itself.
Looking for tampering.
Looking for tampering. And if a forensic analyst tries to capture it or poke at it in memory, the implant doesn't just crash. It initiates a self-delete sequence.
And that sequence erases everything.
Meticulously. It securely overwrites all the files it dropped. It doesn't just delete them, it wipes the data multiple times. It erases shell history, login records, and it sanitizes all the relevant system logs.
It leaves nothing behind, minimizing exposure for the developers and, of course, their customer.
Right. No forensic evidence to track.
Okay, so VoidLink is an intelligent, multi-protocol, kernel-aware, self-destructing commercial weapon. That brings us to Section 4. What does this all mean for the broader threat landscape?
It solidifies the trend that high-value cloud environments are the #1 target, and that the adversaries are getting much, much more skilled. Checkpoint's main takeaway was that VoidLink is, quote, far more advanced than typical Linux malware.
Because it automates the evasion.
It automates evasion and adaptability. It's aiming to provide a guaranteed bypass for most modern security defenses.
And we can connect this back to the wider context we see in the source material. Security leaders are already bracing for this exact level of threat.
Precisely. You see that urgency in reports like the 2026 CISO budget benchmark. CISOs are pouring money into advanced defenses, EDRs, cloud posture management, hardening measures.
And VoidLink is the direct response to that investment.
It's the tool you build to jump over those newly raised walls.
It also confirms the trend we've seen toward these hyper-targeted, sophisticated attacks. We've seen Go Brute Forcer attacking crypto projects, Celic malware going after consumer apps.
And VoidLink takes that same focused approach and applies it to the fundamental infrastructure. The cloud hosts themselves.
So the actionable knowledge here, for you, is about shifting your defensive mindset.
I think so. Security isn't just about blocking a payload anymore. It's about being able to detect that silent profiling that happens moments before the breach.
The impairment checks, the risk score calculation.
Then the deployment of a kernel-specific rootkit. Your defenses have to be capable of spotting slow, subtle, adaptive behaviors, not just a loud smash and grab.
This deep dive has been genuinely illuminating. It's a little terrifying, but illuminating. To sum it all up, VoidLink is an automated, high-intelligence mercenary framework built exclusively for modern cloud environments. It profiles every major provider, it adapts its behavior based on a risk score that it calculates from your own security tools, and it has a self-destruct mechanism that erases all evidence.
And, the level of polish, the meticulous documentation, it all strongly suggests that cybercrime has reached a point of maturity where it operates like a highly structured, almost corporate development model.
They're not just building scripts. They're creating polished, commercialized products.
The attack economy is formalizing.
That is a truly terrifying implication for the future of infrastructure security.
It is. And it raises a final, important provocation for you to consider.
Okay.
Given that VoidLink actively checks for dozens of security solutions and hardening measures before it acts, does this mean that our constant push to implement new, visible defensive measures is now just contributing to the training data for the next generation of automated malware?
So our defenses are inadvertently teaching the malware how to be better.
What does this implied forced training loop mean for how we approach future infrastructure hardening? It's something to mull over as you work to secure your own cloud environments.
Food for thought indeed. Thanks for diving deep with us. We'll catch you on the next one.